Math Analyzers, welcome to your Chapter 3, Lesson 6 video. Now we are going to review factoring. This will be fun. I haven't done this in a while. Okay, blue pen. You guys hit it on me, didn't you? Trying to force me to use purple. All right, here we go. Greatest common factor, GCF. We're going to start there. So greatest common factor is something that can be pulled out of all of the present terms. So it's the biggest thing, that's the greatest part, that can be divided out of every single present, push it this way, every single present piece of the polynomial. Okay, so of course there's an example right here with the procedure. So each of the types of factoring that I'm going to review from Algebra 1 are going to have an example with a procedure. And then of course, we're just going to go in and do it. So I'll do some examples. Obviously, I'm not going to do every single one, but I'm going to pick kind of some classic examples that you'll see a lot, or maybe some of the more challenging ones that you might see. Okay. So let's take a peek at a classic example, which would be something like 18x minus 27. Okay, so here I don't have x's in both terms. So x can't be part of the GCF because I don't have that particular variable in both of the things. So instead, what I'll end up doing is saying, okay, between an 18 and a 27, what number can they both evenly divide by? 9. So I pull a 9 out front, and then I make my set of parentheses. And in the set of parentheses, there needs to be the same number of things as the original. So 18x divided by 9. So 18 divided by 9 is 2x left over. Negative 27 divided by 9. Negative 3 left over. 2 things in the parentheses, 2 things in the original. Your GCF is the factor out front, and the leftover factor is what's in the parentheses behind it. Keep going, right? 6x minus 36, same kind of thing where there's not a variable in both terms, so there's not going to be a variable as part of my GCF. Okay, well, 6 and 36 are both evenly divisible by 6, so here we go. That's my GCF. I make my empty set of parentheses behind it. I need to fill that binomial with 2 terms. 6x divided by 6, well, that's just a 1x left. Negative 36 divided by 6, well, that's a minus 6 left. The x minus 6 is the leftover factor. The 6 in front is the greatest common factor, the GCF factor. Okay, and those are multiplied together as 2 pieces, right? Each is this multiplied piece. Okay, if I redistributed, I'd go back and get that same original polynomial. So we should look at things like number 7, because that's what's really going to be in our equation solving. That is the reason that we review all this factoring. So stuff like this is what we're really going to see in our equation solving. Okay, so let's start with just our numbers. So between a 5 and a 15, what do they have in common? Well, they are both evenly divisible by 5. So that's part of the GCF. Now this time I do have x's in both variables. So what you're looking for is what is the greatest exponent present that you can pull out of each term, which means really what you're looking for is what's the lowest present exponent, because that is what can be pulled out of each of the present x's. All right, so here you've got an x cubed, here you've got an x squared. So an x squared can come out of both terms. So that becomes part of the GCF now. And then you have your leftover. Okay, so now you divide each term by that. Now the 5's, of course, cancel out to a 1. X cubed divided by x squared gives 1x left. So just x, or x to the first power, is what's present. You can consider subtracting the exponents, right? 3 minus 2 is 1. And that's what I have here. Okay, negative 15 divided by 5, well, that's minus 3. Then x squared divided by x squared, well, that's exactly the same number. So it cancels to a 1, which then multiplies by negative 3. And anything times 1 is itself. So when that happens, you consider it canceled out and you put that minus 3 there. That's what's going to be more common. Okay, we're going to see a lot of number 7, a lot of stuff like that. Okay. Sometimes on stuff like number 9, there's not a number that GCFs out of these two things. 12 and 5 don't have a common factor, okay? But x squared and x cubed, they do. And again, it's the lowest present exponent and it's x squared. So that's the only thing that's part of the GCF. Now we make our parentheses and we divide 12x squared divided by x squared. Well, the x squareds cancel out, so just the 12 is left. 5x cubed divided by x squared. Well, we're going to have the 5 for sure. And 3 minus 2 is 1, so 5x is what's left in there. Let's go down and look at number 12. Okay, first of all, when we do see these, we're going to rewrite in descending exponential order. I'm not going to do it right here. It's not really necessary because I'm not solving an equation. But if I were to try and solve something, I would want descending exponential order. So just in the future, know that I would reorder those. But look at all 3 terms. Okay, there's a 36x. Okay, there's an 18x squared. No x in the last term. It's just a 3. So since it's just a 3 that's present here, I can't pull an x out as a GCF because it's not going to be able to come out of this last one. So now the only thing I can consider is, okay, hopefully they're all divisible by 3, and they are. All right, so 3 is my GCF. 36x divided by 3, well, that's a 12x left. 18x squared divided by 3, well, that's a plus 6x squared left. And any number divided by itself is a plus 1. It does not cancel to a 0. We only cancel to a 0 if we add and subtract the exact same value of opposites, right? That's the only way we could get that. So there's always the same number of pieces in the leftover as there were in the original. 1, 2, 3, 1, 2, 3. GCF is one factor, leftover is the other. Okay, what if on something like number 13, all of them are negative? Well, that's when you have 2 options, and it's totally up to you if you want signs to change or not. If you don't want all of the leftover to be negative, then you can pull out a negative as part of the GCF. Notice they all have a y, and they're all divisible by 6, 3, 4, 12. Yep, they're all divisible by 6. So 6y, and you can make that negative if you so choose, can come out. If you're doing that, negative 18 divided by negative 6, well, that's a positive 3y squared. 3 minus 1 is 2. Positive 4y. 2 minus 1 is 1. Positive 12. And you can think of it this way. 1 minus 1 is 0. So there's not a y value present anymore. Or you can say, well, I don't care if the leftover is negative, so I'm just going to pull out a 6y. And then all of these things are just left as minuses instead. But either of those are correct. So that one's up to you and what you're doing with it after the fact. Okay? Cool. Well, that's GCFs. You're going to have plenty of practice with those guys. Oh, my faves. Dots. These are always my faves. The reason I say that is because dot stands for difference of 2 perfect squares or difference of 2 squares, right? For dots, so that you can have a good, cool acronym like that. When I'm factoring the difference of 2 perfect squares, it is literally a perfect square minus a perfect square. Those of you who had me in algebra class remember that I tell you all the time, and this is completely true, but mathematicians, as cool as we are not creative when we name things. We either name things after ourselves or we name things by exactly what is happening. Exactly what is happening is you are subtracting a perfect square and a perfect square. Dots, difference of 2 perfect squares, right? So in these 2 examples, you have the difference of 2 perfect squares because you have a perfect square minus a perfect square. Okay, for both of these. X squared is a perfect square. 16 is a perfect square. You're subtracting them. 4 is a perfect square. X squared is a perfect square. 81 is a perfect square. Y squared is a perfect square. You're subtracting them. That's dots, difference of two perfect squares. When you don't have dots, you cannot factor the way I'm about to show you. So this is not dots. Why not? You're not subtracting. Okay, difference is subtracting. If you're not subtracting, you don't have the difference of two squares. 3 is not a perfect square. That's it. Three is not a perfect square. It can't be dots. It's got to be a perfect square minus a perfect square. And when it is, it always factors the exact same way, which is awesome. It is take the square root of the front term and put it in the fronts of two binomials. Take the square root of the back term, put it in the backs of two binomials, and put different signs between them. I'm sure you remember me explaining this, or your Algebra 1 teacher, or your geometry teacher last year because you ran into this. Take the square root of the front term, put it in the fronts. The square root of g squared is g. Take the square root of the back term. Square root of 81 is 9. Put it in the backs. Different signs between them. Take the square root of the front term. The square root of p squared is p. Put it in the fronts of the two binomials. Take the square root of the back term. Square root of 36 is 6. Different signs between them. That's how it factors every single time. Okay, that's dots. This is dots for you. Now, just make sure that you have a perfect square minus a perfect square, right? Make sure that your exponent is even on your variable. Make sure that your number in front is a perfect square. 49 is a perfect square. I mean, it does require you know your perfect squares, but since I've asked you to memorize those since algebra, and your Algebra 1 teacher has asked you to memorize those multiple times, and you're going to need them memorized in the next chapter, again, right? You want to make sure that you have got these perfect squares down. So any even exponent on a variable is a perfect square. And then, of course, we can list them off for you after we're done with some of these examples. But, you know, out of the first 400 integers, there's only 20 perfect squares. I think we can ask you to memorize those, right? So here, what's the square root of 49? That's a 7. What's the square root of r squared? That's an r. So 7r goes in the fronts of two binomials. Now go to the back term. What's the square root of 25? It's 5. What's the square root of s squared? It's s. So 5s goes in the backs of the two binomials and different signs between them. Okay. What if it's just letters squared like this? Okay, well, that's pretty easy. The square root of m squared is m. So m's in the fronts. The square root of n squared is n. So n's in the backs and different signs between them. Last one, the square root of d to the fourth is d squared. So d squared's in the fronts. And then the square root of 4 is 2. So 2's in the backs and different signs between them. And there you go. That's difference of two squares. Okay. Last type of factoring review. Look at that for you purple lovers. There's now a purple box there. Oh, these are awesome. Factoring trinomials. What times what adds to give me the middles and multiplies to give me the end, right? So here we go. I love these things. These are great. All this stuff is great. You guys are great because you can do this. When you see a trinomial, first of all, put them in descending exponential order. So x squared plus 19x plus 34, right? So descending exponential order. Your exponents are getting smaller as you go. Okay, that's first of all. Now you think, well, what multiplies together to give me 34 that will then add to give me the 19 that's in the middle? Well, it's not 1 and 34 because that adds up to 35. So let's try 2 and 17. 2 plus 17 is 19. So what you do is you put your variable in the front. Basically, you take the square root of x squared. It's x. So your variable singular goes in the front of each of these. And now what you do is you put those two factors that you just named, the 17 and the 2, in the backs of your two binomials. There it is, caught up to me. Look for signs. If your end term is positive, then these two binomials have the same sign in them, and it is the same sign as the middle. Well, the middle was positive. And let's think about that for a second. 17 plus 2 is the 19 we get in the middle. Okay. 17 times 2 is the positive 34 we get at the end. There you are. Let's do the next one. What multiplies together to give me 15 and subtracts to give me 2 in the middle? Wait, why did I say subtracts? If your end term is negative, you are subtracting to get the middle. And the bigger factor of your two factors will have the same sign as the middle. Okay. 1 times 15, so 15 minus 1 is 14. Well, that's not my middle number. 3 times 5 is 15. And 5 minus 3 is 2. So I put my two numbers in there, and I said the bigger factor has to have the same sign as the middle. What's bigger, a 5 or a 3? So 5 has to have the same sign as the middle, the negative. Now, if your end term is negative, these have different signs, and you already have a same sign as the middle, so this will be that leftover sign. That's how we do these every single time. So let me just do another one with a negative at the end, right? Because that tends to be the one that people have trouble with. So right here, number 5, we've got a negative 18 at the end. What multiplies together to give me 18, but subtracts to give me the 3 in the middle, right? Well, let's think. 18 and 1, that subtracts to give me 17. 9 and 2 subtracts to give me 7. 6 and 3. 6 minus 3 is 3. That's what gets me my middle. All right, let's go. Let's go. All right, we got my 6 and my 3. What's the middle sign? It's a positive. The bigger of these two factors has to match that, so that's a positive 6. If the end term is negative, then these are opposite signs, and I already had the positive taken care of. So there we have it. Again, down here, number 7. What multiplies together to give me 42, but subtracts to give me a 1 in the middle? Because, yeah, what this really is a negative 1 right here. We just don't write it in, because if we have a negative x, we have a negative 1x. It's there. Okay, so 42, let's see. Well, 1 and 42 subtracts to give me 41, so it's not that. 2 and 21, well, that subtracts to give me 19, so it's not that. 3 and 14, nope, that's 11. Not 4, not 5, 6 and 7. 7 minus 6 is 1. There we go. Okay. Bigger factor has to match the middle. So the bigger of the two factors is 7, has to match the middle. Negative at the end, so this is the opposite sign. Okay, one more of the minus sign at the end, and then I'll do all those fun pluses. So let's see. 24, what multiplies together to give me 24, but subtracts to give me 5? That would be 8 and 3. 8 and 3. 8 has to have the same sign as the middle. 3 gets the other. Okay, so if your end term is negative, that's the only time you have different signs inside your binomial. Okay, if the end term is negative, it's the only time you have different signs inside your binomial. If your end term is positive, you have the same signs inside the binomial, and they are the same as the middle, which means that the bigger factor is still always matching the sign in the middle. So you can just go by that rule no matter when you're doing this, okay? So what times what gives me 4 and adds up to 5? Never discount a number and itself as factors, right? So 4 and 1 are the factors because 4 plus 1 is 5. So you put those in here. The bigger factor has the same sign as the middle, But also, because this is positive, these two factors have the same sign, and it's the same as the middle. 16, what times what multiplies together to give me 16, adds up to 10? 8 and 2. Both positive. Middle is positive, end is positive, both positive. What times what gives me 28, but adds up to 11? That would be 7 and 4. Again, both positive. And what times what gives me 24, but adds up to 25? That's 24 and 1. Again, both positive. That is how we do factoring our trinomials. Okay? So we've gone through 3 types of factoring. They're all reviewed from from Algebra 1. I expect that you know these. I've actually already done a bunch of stuff with these, but we're doing some review of it because we're going to be doing it a lot more frequently now. Okay? So go ahead, do all that fun factoring homework, and then I shall be seeing you to factor with a greater than 1 on these fun trinomials right here. Okay? So good luck, my fine friends, and reach out if you need something. Goodbye.